Good afternoon. My name is James Little from Mass Spec Interpretation Services. I wanted to give you some additional tips for processing MSMS data files in the Agilent MassHunter software for the NIST MSMS search. This is a quick overview of the basics repeated in the first video I made, plus types of searches that can be performed, the importance of manually entering precursor ion if not imported. That's just an occasional problem, but I need to show you how. Extracting and processing different collision energies, the walking chromatogram, or what some call the walking man, and also expanding chromatograms or spectra. You'll need some additional information to actually make the software work for you. One is the NIST library setup, and this is critical to set up correctly, and then the user can just save the settings and should be able to restore them very easily if something happens to a setting while processing. And the types of MSMS searches, there are three, and that's a part of the library setup document. So it's one and the same. Both of these are included in the same document. The other one of the three searches, the hybrid search is probably the most difficult to understand, but it's a very good way to increase the coverage of your components in your library that are not found there. By using the hybrid search, it expands on them to allow you to identify things that are not present in the database. There's also a table linking the delta mass value, which is one of the key things returned by the hybrid search, to the structure that might have changed versus what's in the library. And also there's training material on how to use the search and some examples. And of course, if you want to learn more, there's a lot in the NIST MSMS search. I created a detailed training video series on how to do that. So let's go to the software now and look at some of these additional tips. So we'll go open MassHunter and we'll open a file, open the data file. We'll open this mixture of pesticides. What you first see when you open the file is essentially a total ion chromatogram of all the ions that occurred during the analysis of the samples. So in this case, this was a targeted analysis. So someone set it up to monitor certain species to get MS spectra for identifications or confirmation, whatever. And so what you're seeing here is it's going along, but then when it goes into the targeted, it jumps between the different parts of the experiment that were assigned by the person that's running the sample, by the operator. And what's happening here is it's doing MS data acquisition, and then it'll do three different voltages, collision voltages, 10, 20, and 40. So this is why it's so ragged. It's jumping between all of those different experiments. So what we need to do is parse it out into the MSMS channels to make it easier to do the MSMS searches. So let's first right-click on the chromatogram at the top and say Extract Chromatograms. And we'll pick the MSMS. You can see both of them are here now. I'm just using my mouse wheel to scroll up and down, so you can look at either one. So here's the MSMS, the compounds. So we'll go to get a spectrum of the MSMS for this compound in about 3.8 minutes. You left click and drag to form a box. And then if you double left click within the box, it'll give you the MS spectrum at the bottom. So it's very easy to get an MSMS spectrum. You can just get a single spectrum, so I'm just going to go to the top and single left click just to make that box go away. And then I'll go to the center of the peak and I can just double left click again, and I'll have the spectrum just at the top, but not the average. It's somewhat nice to get the average because it considers all the voltages, 10, 20, and 40, such that when you go to the library search, you get the average spectrum. So there's really no reason not just to average the whole range of the MSMS spectra to get the one to send to the library. So the bottom here, we have the two different ones we got from the top. And we'll go to the first one we got, which was the average, make it active. And to do the MS search, all you have to do is right click in the spectrum box and go find search using NIST MS program. It'll open the library and do the search. And if you already had it open, it just goes ahead and sends it over. I found sometimes if it gets confused about where to send it, if you have the NIST MSMS search open, it just automatically goes to it. But it really should just open it even if the program is not open. So what do we have here? We have the spectrum that we imported. We've got some statistics about the hits, and we have the different libraries that it found it in. You'll see the first hit, I'm clicking on it with the left mouse button. Now I'll use the up and down arrows. You can see the first few are really the same compound over and over again, just a little bit different hits. And there's different scores, and you have to look at the documentation to see what they all mean. They say that the score is the best overall to do, but you can just left click on something and it resorts by dot product, inverse dot product, partial spectrum search, etc. I think it comes up as sorted by the score. The other thing is we've got so many things that are just the same. You can come up to the title bar up here and go to this best matching only. And it gets rid of all things that have the same CAS number. So that's somewhat handy. Now we're on the first one. I left clicked on the list, which is the result list for the search. And I go down, and now the second best hit is something similar, but you can see the fits drop down to 357. I really like to look at all of them initially when I'm opening the search results. So I usually leave this also off initially. So I'll click on it to get it back so I don't forget to change it in the future. The other thing you can do is you can come up to this filter after you do the search, and both of these things, this best matching only, and the filter only change the results after the search has been done. So it really just filters what you already have. It doesn't really do the search again. So if you click on the filter, you can see you can enable filtering if you wanted to, and you can tell what type precursor. You can decide if you want to include MS3 plus spectra. And I talk a little bit about in the documentation on setting up the library and the library searches why or why not you might want or want not to do that. And you can pick the polarity. So you can say, okay, if you enabled it, you can say, okay, and it'll sort it again using those limitations. But again, I usually keep this off when I'm through, just so when I do another search, it doesn't overlimit the search and get no results. So I keep those wide open initially. So that's pretty much the search. Of course, in the documentation, it talks about the setup. This was for the MSMS search. This is for a search where it limits the search by the precursor. If you'll notice up here in the top part of the display, you'll see that the precursor mass to charge was imported with the spectrum. And so this is a really very specific way to search that limits things. So that's usually the one that I would do first. Occasionally, when you import it for one reason or another, it will not have this precursor. And if it doesn't, just unclick the end spectrum, and then you can enter the value that you want for the precursor mass to charge to 3 or 4 significant figures. But in most of the cases in the Agilent search, it's correct. So I'll leave that checked. You can sort by different scoring systems, etc. You can set the MSMS tolerance. This is set at 100. Probably 10 might be a better place to put it for this instrument. That it limits precursor and things that it finds in the library. You select your libraries here, the 3 main ones for the MSMS from the NIST 2023 version. And you can also do structure searches here, and those don't have to be the same libraries, but you have to set both of those. And that's pretty much what you need to do as far as settings. One that I don't really like to use, I've had some problem where I turn on match IN mode. Most of the time that works fine, but occasionally it's eliminated something and I don't really understand why. So I usually keep that off. So turn that off. So that's pretty much the standard settings. And then after you have it where you want it, you just say save configuration and it'll save it whatever you want to. And then when you want to come back, maybe you change something that you didn't know you changed, you can just restore it to the configuration. So it's always good to save your standard configuration. So that's pretty much the NIST search. There's more details. There's a lot of information in here on ways you can do the search and what you can do with it, but those are pretty much the basics. To get back, it's a nice little icon up here. It says switch to caller. So it automatically goes back to the Agilent MassHunter software so we can get another spectrum. We'll do that search again and right click. So I want to show the other two type searches. So we'll go to search using NIST MS program. It did essentially the same thing again, but this time let's go up to the library search options and pick a different type search. We will do the high resolution, which is not limited by the precursor. So it pretty much tries to match the pattern of your unknown to the patterns in the different MSMS databases from NIST. So we'll just say, okay, change that and say, go. And we got the same results for that. Uh, it just matched the pattern and they're very good. It did find some different things further down. Let's turn on our best matching only. So it has the best hit, that's the correct one. And then the next one down is a little different, aromatics. But indeed, you can see the score is falling from 862 to 776. And if you turn the best matching off, we'll turn that off so we don't forget later. You get a lot of things that match that one because of different collision energies, etc. But I do find limiting the precursor is a much more precise way in most cases, but matching by pattern can be useful also. The other type search you might want to use is you go over to similarity here, click on it, and you go to MSMS hybrid, say OK, and then say go. Again, you get the same result again, but the results you get will be a little different if you look through the list. I'm going to the bottom here. I'm clicking on here. It's the same, that's the same, that's the same. Look at this one though. This is somewhat interesting. It's got a relatively high fit, but the delta mass is different by 27 here between what we had and that. So what's the difference there? This one's probably more easy to understand the delta mass. This is a delta mass of 15. So the difference between our compound and this is that an NH2 has been added to the ring. So you add 16, you take away a hydrogen, the delta mass is 15. So this is what you'll find a lot of times when you do the delta mass searches or the hybrid searches. You'll find things that are similar that'll tell you what something else is based on something in the library. So it's a hybrid search. It looks for differences from the loss from the molecular ion, but also looks at the pattern below and gives a combined score. And this can give you ideas about things that are not in the database. So I highly suggest you give it a try. It works really well in EI data also. And I have that additional link that shows you how to use it, and also gives you a delta mass table that if you saw the 15, what does that indicate? What type group has been added to your structure shown versus the unknown? And so I think you'll find it useful, and you ought to give it a try. So let's go back and set our settings back to where they were. In case we come back, we could restore the settings. I'm just going to go back to where I was, MSMS, and say OK. So that gives you the idea of the three types of searches. I hope those will be useful to you. So let's go and do some more things within MassHunter itself. So I'll go back to here. So what else did I want to show you? I wanted to show you that you can also do the energy levels, like 10, 24 for the collision. This was an average, but you can right-click and go to Extract Chromatograms, come down to the Advanced tab, and you can see the energies that are available, 10, 20, or 40. Those are the ones that were set up in the targeted analysis. So let's look at 10, do ESI, because this is electrospray data. And now we have it. Now if you use your mouse but scroll on your mouse, you can see here's the original, here's the one we did for the average of all the energies, and here's the one that you can see at the top is the 10 volts. So now if we come down to the 3.8 again, I do an average across it. You could have just done a single click, and then I double left click, and we'll have the spectrum on the bottom for the 10 volts only. And you could bring up and plot the 10 and the 20 and the 40 and compare it. But in general, I just use the average, but there might be some advantage to doing it this way. You send that to the search. You have the exact same thing again. You'll get a different fit because this one has less energy put into it than the average did. So we'll go back. So that's pretty much how you select different energies. And you, like I said, you can do all three of them, plot them all, and then scroll between them to get the spectra that you can send to the bottom. To clean up some of this stuff at the bottom, I usually left click in the top one, and then I use the delete key on the keyboard and clean up some of them just by keep hitting going to the next spectrum and hitting delete. So that just kind of cleans up some of our workspace. The other one I want to talk about is the walking man. And to do the walking man, I'm going to go back to the original total ion chromatogram. If you go up here to the top, you'll see this thing that looks like a man walking around a chromatogram. And you click on that to highlight it, and it'll open up a separate window for that so you can see what the results are. Let's go to that one at 3.8, and now we left click there, and now we go to our keypad on our keyboard and just use the right arrow. You can go left or right, but we'll use the right. You can see there's not much signal there. But as you start to get over here, you can read this. This was at the bottom, you can see the fragmentation energy, and this is CID 40. If we go to the next one, just keep paying attention to what's changing here. This would be no energy. It must just be the MS. You come to the next one, it's gone to a CID of 10. See that 10 there? And the next one's gone 20. It's 40. So you could just as well right click and say, I guess you can send this one to the library. I thought you could, but maybe you can't. Let's go up here and see if you can see it up here. Search using NIST MS program. See if it'll go. Yes, it did. I thought it would have something in the pull down menu, but it didn't. So that's pretty much how you do the walking man. And to get out of the walking man, it's best just to go up to this thing that says range select. That'll get rid of the walking man extra spectral pane, make it go away. And now you have the different displays still all available. So that's pretty much all I wanted to show you. One thing, if you want to expand the chromatogram, you right click and drag to box it. You can see it's expanded. And now you go up to the top and make it go back to its original. Same thing for the bottom if you wanted to do it. Right click and drag. And we have the spectrum expanded. If you want to close back up, close it back up. Uh, that's pretty much. I'll show you one more thing. Let's go back and send this to the NIST library. Search library using NIST program. To show you one more menu. If you come up here to the options menu, you'll go to the library spectrum import options. And this is where you set it up for accurate mass. You set it up for the number of decimal places that you want imported. And so there's a lot of parameters here you might want to select. The one I find interesting at times, sometimes when you're doing MSMS, if you don't have your thresholds set correctly, you get a lot of electronic noise, and you can just change this to the percent of the maximum to kind of filter out some of that small, what I call hair on the baseline, the real fine stuff that's just electronic noise. And it'll clean up spectra before they're imported into the NIST search. So this can be handy at times. So I'll go back to the MassHunter, and that's pretty much everything I wanted to show you. I hope this video will be useful to you in taking advantage of some of the extra things within MassHunter and also getting your NIST search set up and using the different NIST search algorithms to identify your unknowns. Especially, I would highly suggest learning how to use the hybrid, though you need to watch a couple of videos on that and learn the principles of it and how to interpret delta mass, etc. Good day.